Hi, this is Jessica Dunn, and I had a request to work a practice problem from Chapter 7. If you go to the Chapter 7 practice problems module, or the section within the Chapter 7 module called practice problems, this question is one of those listed. Okay, so it says that your company has just successfully completed some new R&D work that leads you to expect earnings and dividends to grow at 50% this year, 25% the next year, after which it should return to the 6% industry average. The last dividend paid was $1. What is the value of this stock? So first step is to put this on a timeline. We want to know, what is the value of this stock? The rule is that we go one period after the dividends become constant. So this year we're expecting our dividends to grow at 50%. Next year 25%. And thereafter 6%. So we only have to go to time period 3 because at the end or the beginning of year 2 the growth rate is 6%. So the last dividend paid was $1, so that's D0, and we know that because it was the last dividend paid. I also told you in the instructions to assume that the required return is 13%. So if D0 was $1, that is not included in our calculation, so we first need to calculate D1, which is D0 times 1 plus the growth rate. So 1 times 1 plus 50%. And you use the growth rate for that period leading up to the dividend. So it's $1.50. And then we calculate the dividend for time period 2. So dividend for time period 2 is equal to the last dividend times 1 plus the growth rate. So $1.50 times 1 plus 25%. That gets $1.88. Now we go to dividend 3. Dividend 3 is equal to dividend 2 times 1 plus the growth rate. That's $1.88 times 1 plus 6%. $1.99. Okay, so once we have calculated our dividends, we move on to step 2, which is to use the Gordon model. The Gordon model says that once dividends start growing at a constant rate, then we can find the present value of those future dividends using the Gordon model, which says that the price today is equal to the next dividend payable divided by the required return minus the growth rate. So the price at time period 2 would be equal to the dividend at time period 3 divided by the required return minus that constant growth rate. So $1.99 divided by 13% minus 6%. So divide that by 0.07, 13 minus 6, and we get 28.39. Now yours may be pennies off if you have rounded anywhere in the middle. That shouldn't affect your answer that drastically. So just continue on. But once you've calculated using the Gordon model, the price at time period 2, you can ignore everything after time period 2 because this is the present value of all future dividends. An alternative way to look at it, if you don't wrap your head around that explanation, is that once we use a dividend that we've calculated, we're never going to use it again. So using the Gordon model, we already used dividend 3, so that's gone. We don't have to look at it anymore. Okay, so step 3 then, step 1 was to calculate the dividends to one period after where the growth rate becomes constant. Step 2 was to use the Gordon model. Step 3 is to take the present value of these cash flows. So our cash flow at time period 0 is 0 because there's nothing above the 0 mark. Cash flow at time period 1 is equal to dividend 1, which is $1.50. Cash flow at time period 2 is equal to dividend 2 plus the price at time period 2. And I did that because this dividend 2 here, is not included in the present value of future dividends. So we have to add those two together. So $1.88 plus $28.39. and I get $30.27. Again, if yours is a little bit off due to rounding, that shouldn't affect your answer dramatically. So then you need to push the NPV button, enter in your discount rate of 13%, and then enter down and compute. If you have a graphing calculator, which is what my specific question was to how do you solve this on a graphing calculator, all of your steps are the same, but to put it into your calculator, you're using your net present value function, and the inputs for your net present value is your discount rate, comma, cash flow at time period 0, comma, open braces, and your cash flows separated by commas, close braces, close parentheses. So let's use this information that we put in for our graphing calculator or in our financial calculator, and we know that our required return is our IY, and that's 13%. That's a whole number of 13 because you are in your time value of money function in your graphing calculator. Cash flow at time period 0 is 0, comma, open braces. Cash flow at time period 1 is dividend 1, $1.50. Cash flow at time period 2 is dividend 2 plus the price at time period 2. And you can write it in just like this. Your calculator will add it up for you. You don't have to do it beforehand. And then compute, or enter, excuse me, if you have a graphing calculator. So the answer here would be, enter in my cash flows. Once I open the cash flow register, I need to clear it out. Cash flow at time period 1 is $1.50. And cash flow at time period 2 was $30.27. I'm going to push the NPV button, enter in my discount rate of 13%, and compute. So I get $25.03. Now, if you're looking at the solutions that were generated from the textbook, often your answers will be up to probably 25 cents off because your book asks you to do lots of interim rounding. And in the way that I'm teaching you to do it, there's not a lot of rounding that's taking place. So you're getting a more correct answer with this approach than the approach that the book takes, where you're stopping at multiple spots and rounding the answers and then computing with those rounded answers. So I hope this helps. If you have any other questions, don't hesitate to reach out to me.